Murray Electrical Products is a brand owned by Siemens Industry Incorporated. Siemens is recognized as a global leader in the electrical industry, known for its production of high-quality and reliable electrical products. Murray electrical panels are generally considered reliable and durable. These panels are designed to meet current safety standards and have been implemented in both residential and commercial applications over a number of years. The breakers contained in Murray electrical panels are recognized for their dependability. They are engineered to trip rapidly and reliably when a fault is detected, protecting electrical systems and connected devices. Federal Pacific panels, in contrast, have a documented history of containing defective breakers which are prone to failing to trip during fault conditions. This is a well-known problem that poses a significant safety risk. Murray electrical panels do not exhibit this particular problem. Looking at user feedback and industry experience, Murray electrical panels and breakers generally have a positive reputation for reliability. They are comparable to other major brands of electrical panels such as Square D, Cutler Hammer, and G. Selecting a Murray electrical panel can provide confidence in choosing a reliable and high-quality product for electrical installations. Murray panels and breakers adhere to industry standards and are known for their durability and safety features. When selecting an electrical panel, there are key considerations to ensure a safe and reliable installation. Firstly, it is important to select a panel that is appropriately sized for the electrical load it will serve. This means calculating the total amperage of all circuits that will be connected to the panel and choosing a panel with a higher amperage rating. The National Electrical Code (NEC) provides guidelines for calculating electrical loads, including factors for continuous loads and demand factors for various types of equipment. Secondly, it is important to consider the available space for the panel installation. Electrical panels come in different sizes, and it is necessary to ensure that there is enough physical space to accommodate the panel and its associated wiring. The NEC also specifies minimum working clearances around electrical equipment to allow for safe access and maintenance. Thirdly, the environmental conditions where the panel will be installed must be taken into account. If the panel will be exposed to moisture, dust, or extreme temperatures, a panel with an appropriate enclosure rating should be selected. NEMA, National Electrical Manufacturers Association, ratings indicate the level of protection provided by an enclosure against environmental factors. Fourthly, the type of breakers that are used in the panel should be carefully considered. Breakers are designed to protect electrical circuits from overcurrents and short circuits. Different types of breakers are available for different applications, including standard thermal-magnetic breakers, ground fault circuit interrupters (GFCI), and arc fault circuit interrupters (FSI). GFCI breakers are required in areas where there is a risk of electrical shock, such as bathrooms and kitchens, while FSI breakers are designed to protect against arc faults, which can cause fires. Fifthly, the panel should be installed by a qualified electrician who is familiar with the NEC and local electrical codes. Proper installation is essential to ensure the safety and reliability of the electrical system. This includes properly grounding the panel, making secure connections, and labeling all circuits. Once the panel is installed, it is important to perform regular maintenance to ensure that it continues to operate safely and reliably. This includes inspecting the panel for any signs of damage or corrosion, testing the breakers to ensure that they trip properly, and tightening any loose connections. The NEC provides guidelines for the inspection and maintenance of electrical equipment. Some additional points to consider are, firstly, surge protection. Consider installing surge protection devices, SPDs, at the panel to protect against voltage surges caused by lightning or other electrical disturbances. SPD can help to prevent damage to sensitive electronic equipment. Secondly, future expansion. Choose a panel with enough spare capacity to accommodate future electrical needs. It is generally a good idea to select a panel with more spaces than are currently needed to allow for future expansion. Thirdly, labeling. Clearly label all circuits in the panel to make it easy to identify and troubleshoot electrical problems. Circuit directories should be kept up to date and accurate. Fourthly, grounding. Ensure that the panel is properly grounded to provide a path for fault current to flow back to the source. Proper grounding is essential for electrical safety. Fifthly, bonding. Bond all metallic components of the electrical system together to create a low impedance path for fault current. This helps to reduce the risk of electrical shock. Sixthly, wire size. Use the correct wire size for each circuit based on the amperage rating of the breaker and the length of the circuit. The NEC provides tables for determining the appropriate wire size for different applications. Seventhly, conduit. Protect wires with conduit or other approved raceway to prevent damage and ensure safety. Conduit also helps to prevent electromagnetic interference. Eighthly, torque. Tighten all connections to the proper torque specification to ensure a reliable connection. Loose connections can cause overheating and electrical problems. Ninthly, inspection. Have the installation inspected by a qualified electrical inspector to ensure that it meets all applicable codes and standards. Tenthly, documentation. Keep accurate records of all electrical work, including panel schedules, wiring diagrams, and inspection reports. These records can be helpful for troubleshooting and maintenance. Electrical panels are designed with specific features and ratings to ensure safe and reliable operation. Understanding these features is crucial for proper selection, installation, and maintenance. Firstly, amperage rating. The amperage rating of a panel indicates the maximum amount of current that the panel can safely handle. It is important to select a panel with an amperage rating that is sufficient for the total load of all circuits connected to the panel. Secondly, voltage rating. The voltage rating of a panel indicates the maximum voltage that the panel can safely handle. It is important to select a panel with a voltage rating that is compatible with the voltage of the electrical system. Thirdly, number of spaces. The number of spaces in a panel indicates the number of breakers that can be installed in the panel. It is important to select a panel with enough spaces to accommodate all of the circuits that will be connected to the panel, as well as any future expansion. Fourthly, main breaker. A main breaker is a large breaker that controls the power to the entire panel. It is important to have a main breaker that is sized appropriately for the amperage rating of the panel. Fifthly, branch breakers. Branch breakers are smaller breakers that protect individual circuits. Different types of branch breakers are available for different applications, including standard thermal magnetic breakers, GFCI breakers, and FSI breakers. Sixthly, busbar. The busbar is a metal bar inside the panel that distributes power to the breakers. It is important to have a busbar that is made of a high-quality material and that is properly sized for the amperage rating of the panel. Seventhly, enclosure. The enclosure is the metal box that houses the panel components. It is important to have an enclosure that is properly rated for the environmental conditions in which the panel will be installed. Eighthly, grounding bar. The grounding bar is a metal bar inside the panel that is used to connect the grounding conductors. It is important to have a grounding bar that is properly sized and that is securely connected to the grounding system. Ninthly, neutral bar. The neutral bar is a metal bar inside the panel that is used to connect the neutral conductors. It is important to have a neutral bar that is properly sized and that is securely connected to the neutral system. Tenthly, surge protection. Some panels come with built-in surge protection devices. These devices can help to protect against voltage surges caused by lightning or other electrical disturbances. Different types of electrical panels are used for different applications. Understanding the different types of panels is important for selecting the right panel for a particular installation. Firstly, main lug only MLO panels. MLO panels do not have a main breaker. They are typically used as subpanels, which are panels that are fed from another panel. Secondly, main breaker panels. Main breaker panels have a main breaker that controls the power to the entire panel. They are typically used as service entrance panels, which are the first panels in an electrical system. Thirdly, transfer switch panels. Transfer switch panels are used to switch between two different power sources, such as utility power and generator power. They are typically used in emergency power systems. Fourthly, automatic transfer switch, ATS panels. ATS panels automatically switch between two different power sources when a power outage occurs. They are typically used in critical applications such as hospitals and data centers. Fifthly, manual transfer switch panels. Manual transfer switch panels require a person to manually switch between two different power sources. They are typically used in less critical applications such as homes and small businesses. Sixthly, load centers. Load centers are small electrical panels that are typically used in residential applications. They are typically less expensive than other types of electrical panels. Seventhly, lighting panels. Lighting panels are electrical panels that are specifically designed for lighting circuits. They typically have a large number of spaces for breakers. Eighthly, power distribution units (PDU). PDU are electrical panels that are typically used in data centers and other critical applications. They provide a reliable and efficient way to distribute power to electronic equipment. Ninthly, motor control centers (MCC). MCC are electrical panels that are used to control electric motors. They typically include motor starters, overload relays, and other control devices. Tenthly, combination panels. Combination panels combine different types of electrical panels into a single enclosure. For example, a combination panel might include a main breaker panel and a transfer switch panel. When working with electrical panels, it is important to follow safety precautions to prevent electrical shock and other injuries. Firstly, always turn off the power to the panel before working on it. Use a voltage tester to verify that the power is off. Secondly, wear appropriate personal protective equipment (PPE) such as safety glasses and gloves. Thirdly, use insulated tools. Fourthly, never work on a panel that is wet or damp. Fifthly, never overload a circuit. Sixthly, never bypass a safety device such as a breaker or fuse. Seventhly, if you are not qualified to work on electrical panels, hire a qualified electrician. Eighthly, follow all applicable codes and standards. Ninthly, keep the panel clean and free of debris. Tenthly, inspect the panel regularly for any signs of damage or wear. The National Electrical Code (NEC) is a set of standards for the safe installation of electrical wiring and equipment. It is important to follow the NEC when working with electrical panels. Firstly, Article 100 defines the terms used in the NEC. Secondly, Article 110 covers general requirements for electrical installations. Thirdly, Article 200 covers the use and identification of grounded conductors. Fourthly, Article 210 covers branch circuits. Fifthly, Article 215 covers feeders. Sixthly, Article 220 covers branch circuit, feeder, and service calculations. Seventhly, Article 230 covers services. Eighthly, Article 240 covers overcurrent protection. Ninthly, Article 250 covers grounding and bonding. Tenthly, Article 300 covers general wiring methods. There are many types of circuit breakers used in electrical panels to protect circuits from overcurrents and short circuits. Each type has specific characteristics and applications. Firstly, standard thermal magnetic breakers are the most common type, tripping when excessive current heats a bimetallic strip or when a strong magnetic field is created by a short circuit. Secondly, ground fault circuit interrupters (GFCI) breakers protect against ground faults, which can cause electric shock. They detect imbalances in current between the hot and neutral wires and quickly trip the circuit. Thirdly, arc fault circuit interrupters (FSI) breakers protect against arc faults, which are dangerous electrical arcs that can cause fires. They detect unique signatures of arc faults and trip the circuit. Fourthly, dual-function breakers combine GFCI and FSI protection in a single unit, providing comprehensive safety. Fifthly, shunt trip breakers can be tripped remotely by an external signal, often used in emergency shutdown systems. Sixthly, high interrupting capacity (HIC) breakers are designed to handle very high fault currents, typically used in commercial and industrial applications. Seventhly, series-rated breakers are used in systems where multiple breakers are connected in series with coordinated tripping characteristics to minimize disruptions. Eighthly, molded case circuit breakers, MCCB, are larger breakers used in high current applications, offering adjustable trip settings and advanced protection features. Ninthly, electronic trip circuit breakers use electronic sensors to detect overcurrents and short circuits, providing more precise and adjustable protection. Tenthly, solid-state breakers use solid-state components for tripping, offering faster response times and enhanced reliability. The correct selection and installation of circuit breakers are crucial for electrical safety and system performance. Ensuring that breakers are properly rated for the circuit and application is essential. Electrical codes like the NEC provide guidelines for breaker selection and installation. Regularly inspecting and testing breakers is also important to ensure they function correctly. When installing or replacing an electrical panel, there are several key steps to follow for a safe and compliant installation. Firstly, planning and preparation involves determining the appropriate panel size, amperage rating, and features for the intended application. This includes calculating the electrical load and considering future expansion needs. Secondly, safety precautions are paramount. Always disconnect power to the existing panel before starting any work. Use appropriate personal protective equipment, PPE, such as safety glasses, gloves, and insulated tools. Thirdly, removing the old panel involves carefully disconnecting all wiring from the old panel, labeling each wire for easy reconnection to the new panel. Fourthly, mounting the new panel involves securely mounting the new panel to the wall, ensuring it is level and properly supported. Fifthly, grounding and bonding involves connecting the grounding and bonding conductors to the new panel, ensuring a proper electrical ground. Sixthly, wiring the new panel involves carefully connecting each wire to the corresponding breaker or terminal in the new panel, following the wiring diagram and electrical code requirements. Seventhly, labeling circuits involves clearly labeling each circuit breaker with its corresponding load, making it easy to identify and troubleshoot circuits in the future. Eighthly, testing the installation involves turning on the power to the new panel and testing each circuit breaker to ensure it is functioning correctly. Ninthly, inspection by a qualified electrical inspector is essential to verify that the installation meets all applicable codes and standards. Tenthly, documentation involves keeping accurate records of the installation, including the panel schedule, wiring diagrams, and inspection reports for future reference. Proper installation and maintenance of electrical panels are crucial for ensuring electrical safety and reliability in residential, commercial, and industrial settings. Adhering to electrical codes and best practices is essential for preventing electrical hazards and ensuring the longevity of electrical systems.